Exterior angles of a polygon, and we're going to do this with triangles, but this will work with any polygon. We can create an exterior angle by simply just extending one of the sides of the polygon, or of the triangle in this case, okay? And so it's an angle that's not inside the polygon, it's actually outside. That's why we call it an exterior angle, all right? And we create that angle by just extending one of the sides. For example, in this guy, I've got triangle with angles 1, 2, and 3. If I take any one of these sides, like this bottom side, and I just extend it out a little bit, okay, if I extend that angle, notice it creates another angle next to angle 3. I'll call it angle 4. So angle 4 would be an exterior angle of this polygon. And at each of the corners, I can create an exterior angle. Like here, next to 2, I could extend this side, and that would create an exterior angle next to 2. I could call it angle 5. Okay, and so basically every polygon has exterior angles that we can create just by extending the sides a little bit. All right, for a triangle, there's 3 different exterior angles that I could create here. I could create one going this way and call that angle 6, or I could draw the line the other way. It doesn't matter which way I draw the line to create the exterior angle. I could do it this way and create angle 6 over here. Okay, but I can always create an exterior angle at each of these vertices, at each of these corners, just by extending one of the sides and making an angle on the outside. That's an exterior angle, okay? And so let's look at the measurements for these exterior angles. We're still going to use the same things that we've been using, the idea that the angles inside a triangle add up to 180 degrees. All right, but now we're going to expand out. Not only do we know that angles add up to 180 degrees inside a triangle, we also know that when things form a line, which is what we're doing when we extend the side, those also add up to 180 degrees. So for example, if I wanted to find x, I'm actually going to find it indirectly. I'm going to find something else first. I'm going to find the missing angle inside the triangle first. And so when I look at the angles inside the triangle, I know that they add up to 180 degrees. So if I take the existing angles, the 90 and the 70, those add up to 160 degrees, and then I subtract that from the 180. Okay, so the angles that I already have is 160, so I subtract, I find the missing angle inside the triangle. Well, that's going to be a 20-degree angle. Okay, so 20 degrees. And so now if I know the missing angle is 20 degrees, now let's ignore the triangle and look at the thing that makes a line. When you look, these 2 angles together make a line, and we know that lines have to equal 180 degrees, which means if I do a little subtraction here, 180 minus the 20, well, that means that x is going to have to be, well, 160 degrees. It's got to be a 160-degree angle. Okay? If I do the same thing with the next one here, once again, let's start inside the triangle. I know that inside the triangle, these have to add up to 180 degrees. So these 2 together, if I do the 43 degrees plus the 65 degrees, that's 107 degrees. And now to find the missing angle, I have to do 180 minus that. And so when I subtract these guys, that gives me a 73 degrees. So that's the missing angle inside the triangle. And now I look at this and say, hey, this makes a line right here. And lines have to be 180 degrees as well, which means if I do the 180 minus the 73 degrees, it'll give me the value for y. And so when I subtract these, I get 107. So y equals 107 degrees. Okay? So again, the angles inside the triangle add up to 180, and then those things that form a line add up to 180. So I find the missing angle in the triangle, and now I can find the missing piece of the line. This example, we're doing the same kind of thing, but reversed a little bit. So now I'm looking for a missing angle inside the triangle, but I actually have to start with the missing angle that's part of the line that's formed over here first, okay? And so for this one, I need to find this pair of angles first. So that pair of angles, the one that forms the line, well, those have to add up to 180 degrees. So let's find the missing angle that's there. I'm going to do the 180 degrees minus the 118 degrees, and that gives me 62 degrees. And so the missing angle for this linear pair is right here. It's 62 degrees. So I found that one first. Now let's find the missing angle inside the triangle. So inside the triangle, these 3 angles have to add up to 180, right? So that means if I take the angles that I'm given, these two together is 126 degrees. And so if I want to know, hey, these all add up to 180, I do the 180 degrees minus the 126 degrees, and that gives me a 54 degrees. So now I have my y value at 54 degrees, and that's it. So again, we're still using that idea of, hey, when I form a line, they add up to 180, let's find the missing angle. If I have a triangle, they add up to 180, let's find the missing angle, okay?